Hello, my dear students of Benguet State University. Welcome to our online class. I am your teacher, Jan Lasea.
Ladies and gentlemen, a blessed day to everyone. This is my second lecture on our subject, IT 122, Human-Computer Interaction 2. In my previous lecture, we learned some concepts of interaction design, interactive products that are usable, poor and good design, and what to design. Today, we continue to learn more about the interaction design basics. I present to you Schneiderman 8 Golden Rules. Ben Schneiderman, an American computer scientist, consolidated some implicit facts about designing and came up with the following 8 general guidelines. Number 1. Strive for consistency. By utilizing familiar icons, colors, menu hierarchy, call to actions, and user flows when designing similar situations and sequence of actions. Standardizing the way information is conveyed ensures users are able to apply knowledge from one click to another without the need to learn new representations for the same actions. Consistency plays an important role by helping users become familiar with the digital landscape of your product so they can achieve their goals more easily. Number 2. Cater to universal usability. Enable frequent user to use shortcuts like keyboard shortcut, mouse shortcut, button shortcuts. With increased use comes the demand for quicker methods for completing tasks. Number 3. Offer informative feedback. The user should know where they are at and what is going on at all times. For every action, there should be appropriate human-readable feedback within a reasonable amount of time. The Windows Media Player has poorly designed error messages often show an error code that does not mean anything to the user. As a good designer, you should always seek to give human-readable and meaningful feedback. Number 4. Design dialogues to yield closure. Don't keep your users guessing. Tell them what their action has led them to. For example, users would appreciate a thank you message and a proof of purchase receipt when they have completed an online purchase. Number 5. Prevent errors. Offer simple error handling. No one likes to be told they are wrong, especially your users. Systems should be designed to be as foolproof as possible. But when unavoidable errors occur, ensure users are provided with simple, intuitive, step-by-step instructions to solve the problem as quickly and painlessly as possible. For example, flag the text fields or text box where the users forgot to provide an input in an online form. Number 6. Permit easy reversal of actions. Designers should aim to offer users obvious ways to reverse their actions, like undo command. These reversals should be permitted at various points, whether it occurs after a single action, a data entry, or a whole sequence of actions. Number 7. Support internal locus of control. Allow your users to be the initiators of actions. Give users the sense that they are in full control of events occurring in the digital space. Earn their trust as you design the system to behave as they expect. Lastly, number 8, reduce short-term memory load. Human attention is limited and we are only capable of maintaining around 5 items in our short-term memory at one time. Therefore, interfaces should be as simple as possible with proper information hierarchy and choosing recognition over recall. Recognizing something is always easier than recall because recognition involves perceiving cues that help us reach into our vast memory and allowing relevant information to surface. For example, we often find the format of multiple choice questions easier than short answer questions on a test because it only requires us to recognize the answer rather than recall it from our memory. I present to you Norman's 7 principles. To assess the interaction between human and computers, Donald Norman in 1988 proposed 7 principles. He proposed the 7 stages that can be used to transform difficult tasks. Following are the 7 principles of Norman. Number 1, use both knowledge inward and knowledge in the head. Number 2, simplify task structures. Number 3, make things visible. Number 4, get the mapping right. User mental mode is equal to conceptual mode is equal to design model. Number 5, convert constraints into advantages. Physical constraints, cultural constraints, technological constraints. Number 6, design for error, prevent error, and offer error handling. Finally, number 7, when all else fails, standardize and consistency. What is interaction design? Interaction design means designing interactive products to support people in their everyday and working lives. In particular, it is about creating user experiences that enhance and extend the way people work, communicate, and interact. We know GRAD describes it as the design of spaces for human communication and interaction. In this sense, it is about finding ways of supporting people. This contrasts with software engineering, which focuses primarily on the production of software solutions for given applications. What is involved in the process of interaction design? Essentially, the process of interaction design involves 4 basic activities. Number 1, identifying needs and establishing requirements. Number 2, developing alternative designs that meet those requirements. Number 3, building interactive versions of the designs so that they can be communicated and assessed. And number 4, activity, evaluating what is being built throughout the process. Three key characteristics of the interaction design process. Number 1, users should be involved through the development of the project or your client or your customer. Number 2, specific usability and user experience goals should be identified, clearly documented, and agreed upon at the beginning of the project. And number 3, iteration through the 4 basic activities that I discussed previously is inevitable, unavoidable. The goals of interaction design. There are 2 goals of interaction design. First is usability goals, and second is user experience goals. Number 1, usability goals. Usability is generally regarded as ensuring that interactive products are easy to learn, effective to use, and enjoyable from the user's perspective. It involves optimizing the interactions people have with interactive products to enable them to carry out their activities at work, school, and in their everyday life. More specifically, Usability is broken down into the following goals: effective to use or effectiveness, efficient to use or efficiency, safe to use or safety, have good utility or utility, easy to learn, learnability, easy to remember how to use or memorability. Question: is the system capable of allowing people to learn well, carry out their work efficiently, access the information they need, buy the goods they want, and so on? Answer: efficiency refers to the way a system supports users in carrying out their task. The marble answering machine described was considered efficient in that it let the user carry out common tasks, for example, listening to messages through a minimal number of steps. In contrast, the voicemail system was considered inefficient because it required the user to carry out many steps and learn an arbitrary set of sequences for the same common task. This implies that an efficient way of supporting common tasks is to let the user use single button or key presses. Another question: once users have learned how to use a system to carry out their tasks, can they sustain a high level of productivity? Answer: safety involves protecting the user from dangerous conditions and undesirable situations. In relation to the first ergonomic aspect, it refers to the external conditions where people work. For example, where there are hazardous conditions like X-ray machines or chemical plants, operators should be able to interact with and control computer-based systems remotely. The second aspect refers to helping any kind of user and any kind of situation avoid the dangers of carrying out unwanted actions accidentally. It also refers to the perceived fears users might have of the consequences of making errors and how this affects their behavior. Continuation of the answer to the previous question: to make computer-based systems safer in this sense involves preventing the user from making serious errors by reducing the risk of wrong keys buttons being mistakenly activated. An example is not placing the quit or delete file command right next to the save command on a menu, and providing users with various means of recovery should they make errors. Safe interactive system should engender confidence and allow the user to opportunity to explore the interface to try out new operations. This menu on my right is not safe because the save button is close to the quit button, whereas the menu on my left is a safe menu. Continuation of the answer to the previous question: other safety mechanisms include undo facilities and confirmatory dialog boxes that give users another chance to consider their intentions. A well-known example used in email applications is the appearance of a dialog box after the user has highlighted messages to be deleted, saying, "Are you sure you want to delete all these messages? OK or cancel. Press yes or no." Another question: does the system provide an appropriate set of functions that enable users to carry out all their tasks in the way they want to do them? Answer: learnability refers to how easy a system is to learn to use. It is well known that people do not like spending a long time learning how to use a system. They want to get started straight away and become competent at carrying out tasks without too much effort. This is especially so for interactive products intended for everyday use. For example, interactive TV, email, and those used only infrequently, for example, video conferencing. To a certain extent, people are prepared to spend longer learning more complex systems that provide a wider range of functionality, for example, web authoring tools, word processors. In this situation, CD-ROM and online tutorials can help by providing interactive step-by-step material with hands-on exercises. However, many people find this tedious and often difficult to relate to the task they want to accomplish. A key concern is determining how much time users are prepared to spend learning a system. There seems little point in developing a range of functionality if the majority of users are unable or not prepared to spend time learning how to use it. Question: how easy is it and how long does it take to get started using a system to perform core tasks and to learn the range of operations to perform a wider set of tasks? Answer: memorability refers to how easy a system is to remember how to use. Once learned, this is especially important for interactive systems that are used infrequently. If users have not used a system or an operation for a few months or longer, they should be able to remember or at least rapidly be reminded how to use it. Users should not have to keep relearning how to carry out tasks. Unfortunately, this tends to happen when the operations required to be learned are obscure, illogical, or poorly sequenced. Users need to be helped to remember how to do tasks. There are many ways of designing the interaction to support this. For example, users can be helped to remember the sequence of operations at different stages of a task through meaningful icons, command names, and menu options. Also, structuring options and icons so that they are placed in relevant categories of options. For example, placing all the drawing tools in the same place on the screen can help the user remember where to look to find a particular tool at a given stage of a task. And number 2, user experience goals. Interaction design is increasingly concerning itself with creating systems that are satisfying, enjoyable, fun, entertaining, helpful, motivating, aesthetically pleasing, supportive of creativity, rewarding, emotionally fulfilling. I posted your second assignment in our Google Classroom. Please answer and accomplish it.
That ends our topic for today. I hope you have learned in my class. Thank you for watching. Carry on until tomorrow. God bless us.